Why, hello there again. Now, we're going to have a look at how to work with the special triangles and finding exact values within the unit circle, but now what we're going to do is we're going to work with radians. So, let's check it out. Now, this one says find the exact value of cos of 5 pi on 4. Now, it's just exactly the same type of process as what we were doing when we were working with degrees, but now we're working with radians. So, the very first thing I need to do is figure out which quadrant it's going to be in. Now, to do this, we've got to look at the 5 pi on 4. If I'm talking about 5 pi on 4, well, I know pi is around to here, and I need to figure out what 5 pi on 4 is. Now, the easiest way to do this is you go 5 divided by 4, well, it's going to be 1 and 1/4, isn't it? So therefore, it's going to be the same as saying 1 pi and 1/4 pi. So therefore, it's going to take me down into the third quadrant. So let's see if this is actually true. So we draw a line to 5 pi on 4, and that's exactly where it is. Excellent. So in terms of that, we know that that's going to be the same as saying pi plus pi on 4. So 5 pi on 4 is the same as saying pi plus pi on 4, and that's in the third quadrant, as you can see. Now, that's all well and good. We know that pi plus pi on 4 is the same as saying 5 pi on 4, but how can we use this in order to figure out what cos of 5 pi on 4 is going to be? Well, let's just have a think about it first of all. We can have a look at this and we can figure out, well, that it's in the third quadrant, and because tan's the only one that's positive in the third quadrant, what will the answer be? Will it be positive or negative? Well, it's going to be negative, isn't it? Because we're dealing with cos, as you can see up here. But in terms of the magnitude, well, we can use symmetry in order to be able to figure out what it's going to be, or the size of it's going to be. And to do that, we use this part here, the pi on 4. So what I'm going to do is I'm actually going to use the angle of pi on 4 in the first quadrant to help us out. So let's go through and do that. We're going to do cos of 5 pi on 4 is the same as saying cos of pi plus pi on 4. Now it's always this second part that's going to tell us the angle in the first quadrant. So as you can see here, it's pi on 4 from here to here. Now in terms of cos of pi on 4, that's going to give us this answer, which we're not 100% sure on what it is just yet. But of course, it's going to be this magnitude here. But when I'm talking about it being over this end, well, of course, it's going to be a negative, as you can see. So therefore, the answer is going to be the same as saying a negative cos of pi on 4. That is, it's a negative answer, but it's got the same magnitude as what cos of pi on 4 does. So what's negative cos of pi on 4 going to equal? Well, let's have a look. We know that we're dealing with SOHCAHTOA, and because we're dealing with cos, we're going to work with the adjacent and the hypotenuse of pi on 4. So pi on 4, well, there's both of them, so it doesn't matter what we do. So we'll go pi on 4 for this one. The adjacent and the hypotenuse means that cos is going to be equal to 1 on root 2. But we're going to be negative, so it's going to be negative 1 on root 2. Aha! Now, of course, we cannot have root 2 on the bottom, so to rationalise it, it becomes root 2 on 2, or negative root 2 on 2, because we're dealing with cos in the third quadrant. So let's now have a look at another example, shall we? Let's have a look at finding the exact value of sine of 7 pi on 6. Alright, so we need to figure out where 7 pi on 6 is going to be. So let's just have a think about this for a second. 7 pi on 6, well, we know that pi goes around to here. In terms of 7 over 6, well, that's going to be 1 and 1/6, isn't it? So 1 pi and 1/6 of pi is going to come up down just to pretty much here, isn't it? So let's go through and plot it. Draw a line to where theta being 7 pi on 6 is. Alright, well, it's right there, isn't it? And of course, that therefore, around from here, is going to be 7 pi on 6, or in other words, it's the same as saying pi plus pi on 6 in the third quadrant. Now, why is this relevant to us, or why is this handy? Well, because we can use the pi on 6 to figure out how big the angle will be in the first quadrant, so we can find out the magnitude. And also, of course, because we know that tan is the only one that's positive, and we're dealing with sine, we're actually going to get a negative answer. So let's go through and see that all work and come into play. So, of course, let's write down 7 pi, or sine of 7 pi on 6 is equal to sine of pi plus pi on 6, as we know. Now, we also know that it's going to be negative, and we also know we're dealing with pi on 6 in terms of the magnitude. So therefore, as you can see here, the magnitude is going to be up to here, and in terms of it where it is at, it's going to be the negative part. So you're going to get negative sine of pi on 6, and that's going to give us our answer. So let's go through and figure out what negative sine of pi on 6 will be. Well, SOHCAHTOA, and we're going to work with a triangle that has pi on 6 in it. Now, sine of pi on 6, sine, so it's opposite and hypotenuse, 1 over 2. So therefore, our answer is going to be -1/2, which of course you can actually see that down here, can't you? Alright, so therefore, as you can see, sine of 7 pi on 6 is the same as saying -1/2. Alright, so you're going to see this picture as we go through out this topic and throughout the whole unit really, that looks like this. Now it probably doesn't make too much sense when you have a look here, but what it's actually telling you is how to work with the unit circle. So let's go through and have a look at it, shall we? We've got a point here, alright, that's our point P, and of course it's got an angle of theta. Now as you can see here, that's going to tell us our sine value along here, and it's also going to tell us our cos value. We can use both of them to figure out our tan value. Now in order to figure out what the sine value is here, you can see I can trace it all the way across to here. It's going to give us the same sine value, therefore sine's positive. And then over here, while we're talking about pi minus theta, because we're always talking about the horizontal axis. If you have a think about to all of the worked examples that we've had a look at, we're always working from the horizontal axis. That is, we go around to pi, then we subtract theta, and that's going to give us our theta there. And of course you can figure out the two parts here as well with sine and cos. In this one, in the third quadrant, as you can see, we've got pi, so we're going around to pi, and then we plus our theta. So this point here is always going to be known as pi plus theta, or whatever the angle is. And then over to this one, well, it's going to be the same as going all the way around to 2 pi, because we always go from the horizontal axis, the closest one that is. And then, of course, we are going to subtract theta. So it's going to be 2 pi minus our theta, because, of course, our theta in this one, and this one, and this one are all the same. And that's what we need to work with when we're dealing with symmetry. We've always got to figure out the angle from the horizontal axis around to the line. The angle from the horizontal axis around to the line. Angle from the horizontal axis around to the line. And of course, the angle from the horizontal axis around to the line. And that will then help us out with symmetry to figure out the angle in the first quadrant. Because this angle here, this angle here, this angle here, and this angle here are all the same. So there you have it, guys. That's how we work with symmetry within the unit circle. Of course, if you do get stuck, make sure you come and ask me for some help. And also, you can also look up different other YouTube videos too that might be able to explain it in another way for you. Alright, best of luck.